This is the second part or a follow-up video for my first video about XBee to XBee, direct wireless communication and switching. The goal is to program the XBee to communicate independently and work as a remote switch. So that is without the aid of a microcontroller. So on this part, I am going to show how each XBee should be configured via the XCTU software so that one can function as a remote switch or as a transmitter and the other as a receiver, which can turn on and off the LED that is attached to it. First, these are the parts that we need. Well, we need at least two XBee, one for the transmitter and one for the receiver. As a take note, I have marked each one of them. And we need an FTDI board so we can connect the XBee to the PC via the USB cable, and so we can program it with the XCTU software. So first, let's configure the transmitter and make sure that the XBee is seated properly to the FTDI board in the proper orientation. Next, let's connect the USB cable, which is right now hooked up to the PC USB board or port. Now the red LED is turned on, meaning that the XBee is connected properly. So we are now ready to program it with our XCTU software on our desktop. Now we are ready to launch the XCTU software to configure our transmitter. Now the XCTU has detected the USB serial port COM6. That means we are connected at that communication port. So let's test if that is properly connected. Now communication with modem is okay, and you can see the modem type and the serial number. This serial number is printed at the back of the XBee if you are going to look at that. Let's click OK. Then next, let's go to modem configuration tab and let's read what is inside the XBee, what are configuration that is existing there. If you can see, all those blue text is now the changes that has been made since the factory default. I've made all those changes and actually those are configuration as for this XBee as a transmitter. What we're going to do for sake of demonstration, we need to make another we need to repeat all those entries, and to do that we need to restore it again to its factory default. It's always a good idea before making a new settings or configuration. You need to restore the XBee to its factory setting in order to remove all those unwanted old setup which you may conflict or confuse you with the expected outcome. Let's restore that, and you can see here, yeah, resetting 80 commands, restore defaults complete. So all those value has been restored to the factory default, and to verify that we can read, and let's see what is written now, the new on the inside the XBee. So it's now all the green text are now in a factory default value, except for this one which I have no idea, could be that is by default already. Now first we need to have a channel. By default it has already a channel, I call it C channel, but we can put a unique one. We need to enter two-digit value, let's say channel 10. Now take note, if you enter more than required, it turns red, that is, or that means that it is not, you are overdoing it. Next, we need the PAN ID. Well, by default, this is the default PAN ID. We don't need to change that, but for uniqueness, we can add our own unique value. Let's say 1, 2, 3, 4. Okay, that's our new PAN ID. Next, we need to put an address to our transmitter. Make it, let's mark it as 1. Or you can put the same number, this number here, the serial number, so you will have a unique address and it's not easy to interfere. So your XBee will not be interfered by the other XBees. Anyhow, for simplicity, we'll make it or mark it as 1. Now the transmitter need to communicate with another XBee, and we need to identify its address. And that is the address of the receiver, so we will mark it. What is the address of the receiver? We'll mark it as 2. And once you mark it, when we configure the receiver, we need to maintain this value at the receiver's 16-bit source address. And when you are configuring the receiver, the destination address should be 1, which is this transmitter source address. So since we are now configuring for the transmitter, so we mark it as 1. Next is the serial interface. We need to write how much BPS or speed are we going to transmit at what speed. That is 9600 by default, and we will not change that. We will have it by default, so we will not change anything on the serial interface folder. Now on the I/O settings, we need to change the pin 20. Now all of this value here, D0 from D8, that corresponds to a pin number in the physical pin number on your transmitter XBee or on your XBee. So the pin 20 starts with D0, pin 19 D1, pin 18 D2, and up to pin 11, which is D8, mark as D8. Since we need to hook up a button switch to the pin number 20, we need to configure that pin as a digital input. So it will be ready to receive an input signal that is either a 0 volts or a low signal, or a high signal which is 3.3 volts. XBee accepts maximum of 3.3 volts. So depends on the channel, or depends on the input that the transmitter is receiving from the press of a button. Then it sends the same signal to your receiver, which your receiver will process that, and it will either turn on the LED or turned off. Next, it has an internal pull-up resistor, and we need to disable it because we need to put a pull-down resistor on the transmitter, which is connected to protect the input pin or pin 20 of the transmitter. Next, we need a samples before transmission. One means you will transmit, XBee is transmitting all any data it is coming or receiving. So let's put some 5 samples to collect before any transmission. And then sample rate. Here at the bottom you have the definition of each item you are changing. So for sample rate, we'll try to make a decent 20 milliseconds. So the definition is here. I'm highlighting it. Next, I/O line passing. We don't need to change it now for the transmitter, but we will change it when we start configuring the receiver. So that's all. Let's recap. Under network and security folder, we changed 4 items. We set a unique channel, unique PAN ID, and we set a destination address low to a unique 2 value that is for the receiver, and a 16-bit source address for the transmitter, which is marked as 1. And next, we have not changed anything until in the I/O settings. So we mark pin number 20 as a digital input, and we disable the pull-up resistor or the internal pull-up resistor. And for a decent transmission, we put 5 milliseconds, or rather 5 samples before the transmitter would transmit the value. And we read at a sample rate of a 20 milliseconds. Other than that, we have not changed anything. Only here and here. So we are now ready to upload that or write that to the XBee memory of the transmitter. Let's click write. Getting modem type OK. Modem's firmware is not updated. Well, if you want to update your firmware here, I believe this is the latest version. Yeah, you just click that, and when you click write, first it will try to search for an update before it will upload your selected configuration. Now let's yeah, it all everything has been written and complete, and let's read that value. Let's read the memory of the XBee, and let's see if it's all indeed written correctly. So all our changes turns into blue. We have networking and security folder for item, and we have on the I/O settings also 4 items. So okay, so the transmitter is now configured properly. Next, we are ready to configure the receiver. Now let's go back to our receivers, and we need to disconnect the USB and remove the already configured transmitter there on his place, and we'll replace that with the receiver. Again, make sure that the XBee is seated properly at the right position and orientation. Now, again, connect the USB cable, and it is now connected. And let's go back to the uh, desktop to program the receiver with the XCTU software. Now let us launch another XCTU window. Take note that this one here is the configuration for the transmitter. We will not close that, so we can compare afterwards the difference between the receiver and the transmitter configuration. So this new window is for the receiver, and the USB port is connected at COM6. And again, as a good practice, we will always test the connection. And now you can see communication with modem is okay, and the serial number is now different. So that's for the receiver. Go to modem configuration again, and let's read what is the whatever existing inside the receiver. And you can see there is some configuration marked in blue text. Yeah. So we will restore it again to factory default. So we need to make sure that yeah, there is no unwanted, there is no unwanted setup. Yeah, resetting 80 command, restore defaults complete. So let's read. All those blue texts are all gone, meaning these are all new or default settings. So again, let's start with the configuration. In the transmitter here, we have got mark it. We use channel 10, and so here with the receiver, we'll mark it channel 10. Pan ID, it should be the same as the transmitter. We got here 1 2 3 4, so we type 1 2 3 4. Destination address low. On the transmitter, we address the destination to 2, that is the receiver, and our destination now will be for the transmitter, so we will mark it as 1, which is now, you can see the difference, 1 for the receiver, and 2 for the transmitter on the destination address low. Now let's mark the receiver as 2. Why? Because we mark it as 2 in our destination address in the transmitter here and here now. So that's it. We have 4 items there changed. Next we need to change is the, yeah, we will not change the modem speed. It should remain 9600 bps, and so with the, yes, and so with the transmitter. Okay, it should always the same. If you change here, you need to change there. So let's go on the I/O settings. On the receiver, we will hook up the LED at pin 20 also, but in this case we need to configure it as a digital output pin and set it by default as low. So meaning when the receiver is not receiving anything from the transmitter, the LED is by default turned off. If you will set that high, if it's not receiving or it is not in active connection with the transmitter, the LED will always turn on. Okay, but we'll select it to be low. That's the pin 20. Again, same as the transmitter. All XBee have on one side pin 20 up to pin 11. So we will utilize only a matching pin with the transmitter, which is the pin 20, and here it is identified in the XCTU as D0. So same with the transmitter. Well, except this is digital output, on the transmitter that is digital input. Yeah, so that's number 3. Here, number 4, that's digital output. We need to enable the internal resistor, so it will protect an overcurrent from the, will protect our pin number 20 from overcurrent from the LED. Next is, we don't need sample because receiver will only receive data from the transmitter, so it will not transfer anything or communicate or yeah, so we will not do anything with those two values. Next, yeah, as I mentioned before, we need to enable the IO line passing, which is very important. Let's mark it as 1. Without enabling it, then every time the receiver is receiving a high signal from the transmitter, that is when you press the button, it will acknowledge that the receiver will acknowledge that signal, but it will not uh, pass through the LED power line. So we need, this one will link the XBee to the LED, a line connection. So that's it. So for, we have 1 item on IO line passing and 2 item on IO settings. On the transmitter, we have nothing for the IO passing. Yes, nothing there. And IO settings, this is the difference. Yeah, that's the difference between the two. And next, on the network and security settings, that's the difference. We are now ready to upload that to the memory of the transmit or the receiver, and that's all the text now that we changed turned to blue. That means it's all written. Let's read that again if it can be read. Yes, so all are embedded for the receiver and it is now readily configured. So those are the configuration, the receiver and the transmitter. So this is the setup of the 2XB which we have just configured. And just briefly, on the left is the XBee transmitter. And if we recall, the pin 20 of the transmitter is configured as a digital input pin. So it can receive the signal at the push of the button or at a release of the button. So on the right, this is the XBee receiver and its pin 20 is connected to an LED and the same pin is configured as a digital output pin on the XCTU software which we have just made earlier. And yeah, these two XBee is ready to communicate independently without the aid of a microcontroller. More on details on how these two setup and wiring connection is explained on the first part of the video which I have posted a few months ago. Uh, for now, this video focus only on how to configure these two XBee via the XCTU software. So we end this presentation at this point.